Okay, so it just started recording and then now I'm going to display my screen. And you guys tell me if you can see it, okay? Just give me 1 second. Can you see my screen now?
Yeah.
Yep.
Okay, perfect. So I'm just going to use my calculator. So all the questions are the same. For question 2, the tricky part is finding 10, right? And you chose C. You could have chosen anyone, I guess. Let's do C and D, okay? Because one of them will D might be interesting. D is very interesting. Okay, so let's do 2 C and D, okay?
Okay.
So 2 gonna make this a little thicker. 2 C. We have theta is equals to 150, right?
Yes.
So sine theta will just be sine of 150. And when you use your calculator, sine of 150, I think will give you 0.5. Right. So you get 0.5 for this. This is not an issue, right?
Yeah.
Cos of 150 will be an issue because you're going to get a decimals. So cos of 150 is minus 0.866. So that means the exact value is what? Minus?
I forgot.
Square root of 3 over 2, okay? So it's either square root of 2 over 2 or square root of 3 over 2. There's only two possibilities, okay?
I have a question.
Yeah.
I thought we had to do the sine inverse and then the angle to get that? Or was that for the other deltas?
No, here they're asking you to find the value of sine, cosine, and tangent. Okay, so when they're asking you to find the value of theta, when they're asking you to find the angle itself, right? That's when you do sine inverse. When the angle is given, then you find sine and cos directly because there's nothing to solve for. The angle is already given to you, right? But
Okay.
if something like this, if the question was sine theta is equals to 0.5, find theta, then you would have to take sine inverse, but there will be two solutions. So you kind of have to draw this out to figure out what your two solutions are.
Okay.
Okay. So yeah, understand, I guess this is a good question. Understand when you're taking sine inverse and when you're not. The only time you're taking sine inverse, cos inverse, and all that stuff is when the angle is not already given to you.
Okay.
Okay. And now tan is tricky. So tan, I'm still using my eraser. Okay. So tan theta, right, is equals to, you guys know this, right? Sine theta over cos theta. Have you seen this in grade 10?
Not really, actually.
Not really? Okay. Tan is sine over cos, okay?
Okay.
It's just an identity. So like you kind of have to know this fact. And I think I showed this to you in the video. But I kind of like did a question in many ways, and maybe you didn't like this way, so you didn't really pay attention to it. But anyway, just know this this fact: tan is always sine over cos. Okay, so that means, right, using this fact, right. So this is just an arrow, right? So tan, I know what my angle is, right? My angle is 150, so tan of 150 will just equals to. I'm just gonna move this. What do you guys think? What should it equal to? Sine of? I know what my angle is, right? I know what theta is, so it will be what? Sine of 150 over cos of 150, right?
Yeah.
But I know what those values are, right? I know what those values are. So sine of 150 is here. Let me use my pencil. So sine of 150 is here, right? So it will just be 0.5 over minus 3 square rooted 2, okay? And then you kind of have to make this look a little nicer. So I guess what you should do is when you're finding tan, use fractions. It will be a little easier, okay? So 0.5 is a half. And if you don't have to, but it's just it will make more sense. But you don't have to, okay? So what do I mean by that? So instead of 0.5, let's say if I use half, okay? Because then I can multiply my two fractions. You see, when you're dividing a fraction by a fraction, it becomes very, doesn't look nice, okay? But then you can use the fact that division is the same as multiplication if you multiply by the reciprocal, right? So this is just equals to a half. So instead of dividing, I'm going to multiply and then flip my denominator, right? So like the fraction in the denominator. So this will just be 2 over square root of -3. Does that kind of make sense?
Yeah.
Right, so this is kind of like what you did in elementary school, right? When you divide two fractions, you can, instead of dividing, you can multiply, but you'll have to take the reciprocal of the denominator. Jessica, does that kind of make sense?
Yeah.
And then when you multiply fractions, right, you just multiply the numerator by the numerator, denominator by the denominator. So if you want, you can multiply and then simplify afterwards, or you could simplify before and then multiply, okay? So how can you simplify before? Well, 2 divides 2, right? And then this just becomes 1. That's one way of doing it. And your final answer will be 1 over minus square root of 3, but you can put the minus up here, okay? But maybe the textbook is not giving you this as your answer because they're rationalizing it, right? Because look, you cannot have a square root in your denominator. So if you give this to me as your answer, it's fine. But just know that your denominator cannot be an irrational number. So you multiply by square root of 3 and you multiply by square root of 3. Okay, so this is kind of like what we did before this unit, right? So in radicals, right? So square root of 3 over square root of 3 is just 1, right? So when you multiply by 1, you're not changing its value. But what you will be changing is the denominator, okay? It will no longer be an irrational number. So -1. Oh, by the way, I brought this -1 on top over here, okay? So you can do that. Or does that make sense, right? You could have put the minus over here, but then it wouldn't be over here, or you can put it on top. It doesn't matter, okay? Usually in math, like the convention is to keep the minus on top in your numerator, but it's just a convention, okay? That doesn't mean that if it's in the denominator, it's wrong, okay? And now when you rationalize this, so -1 times square root of 3 is just negative square root of 3. And square root of 3 times square root of 3 will just be 3, okay? Is that, can someone check, is that what they have in the book?
Yeah.
Minus square root of 3 over 3?
Yeah, that's what they have.
Okay, yeah, because they're rationalizing, right? As you can see at this stage. Does the rationalizing part make sense?
Yeah.
Okay. If you don't rationalize, I'm not gonna be picky, okay? So but yeah, I mean, just know that it's not that difficult to rationalize this one, but if you forget, then that's not that big of a deal. It's just that you have to understand why this is your answer. So when I guess what I'm trying to tell you is that when you're comparing your answers in the textbook, and let's say you forgot to rationalize, you should know that, oh, okay, I have the right answer. It's just that I did not rationalize. Okay, that's what I want you to understand. Like when you're comparing answers, you should know why your answer is also right. And did this make sense?
Yeah.
Yeah.
Okay, so now the next one, question 2D is difficult. So let's do that one. It's difficult. Why? Why do you think it's difficult? So just by looking at this picture, what do you think? I mean, you could use your calculator, but what do you think my cosine sine value are if you look at the picture? So
Wouldn't they be 0?
one of them is 0. Which one will be 0?
The x.
The x. Yeah, the x, which is your cos or sine value.
It's your cos, isn't it?
Yeah. X is your cos value. Okay, so see that's where the problem is. Because tan theta, so sine of 90 is equals to 1, because that's the maximum value that you can have. Okay, and again, if you're confused, right, I kind of like drew the circle and then I showed you how those values are changing. But if that's too complicated, don't worry about it. Okay, just take the calculator and then it will give you the answer. Cos of 90 is equals to 0. Right? Now the problem is tan of 90 is equals to sine of 90 over cos of 90, right? Because tan is just sine over cos, right? Right,
Yeah.
using the fact that tan theta is equals to sine theta over cos theta. Okay, so using this identity, I guess. Now, sine theta I know is 1, but what's cos theta? Cos of 90. Or sine of 90 is 1. What's cos of 90?
0.
0. So what's the problem here?
Your denominator can't be 0.
So tan of 90 is actually undefined, okay? So yeah, and we'll talk about this a little bit. Dividing by 0, you know what it looks like in a graph of a function. It becomes an asymptote, okay? So but we'll get there. Okay, so this is undefined, right? Because obviously you can't divide by 0. Okay, so this one was kind of tricky. But did it kind of make sense?
Now it does.
Okay. Is anyone else is there anyone else in the chat, or is it just the two of
No,
us?
it's just us right now.
Okay, okay. I'm hoping someone might show up. But anyway, it's still being recorded, so that's great. So good questions. I think I'm gonna change my notes a little bit for next year. So I'm gonna be including yeah, finding exact values of tan, right? So that's something that I did not do. But if you use this identity, it's once you find sine and cos, tan is just a ratio of sine over cos. Okay. Any other questions?
I know I already emailed you about this, but if you could just go over question 16 again.
16? Yeah, yeah, sure. So 16, I mean, you could draw it out.
I tried to, and it didn't make sense to me. I don't know why.
Okay, it will work out. It will work out. But you know the drawing will be complicated. So let's do this without the drawing first, and then let's do it with the drawing. Okay, so 16 again. You know I'm gonna use my special identity that tan theta is equals to sine theta over cos theta, right? And now I have I only have one unknown, right? What am I looking for? I'm looking for sine theta. Okay. So I know what my value for cos theta is. I know my value for tan theta. So I can solve for cos theta, right? Using this, it's kind of like a formula if you want, okay? So tan theta is 2 square root of 6, right? Is equals to, and my cos theta is equals to 1 over 5. I don't know what my sine theta is, okay? And then you multiply. cross multiply. Okay, that's one way to solve this. Okay, so does everyone understand how to cross multiply? Okay, before I cross multiply, let me tell you something. So to cross multiply, you need to have fractions on both sides, right? My right hand side is good because maybe let me make this look a little nicer. This looks like an 8. So let's just make this look like an S. So this is sine theta, right? So sine. Now, again, there's many ways of solving for sine theta. The best way I think would be to cross multiply. And I need fractions on both sides. So right hand side is fine. I have a denominator. I have a numerator. Right hand side, I only have a numerator. But remember, if you only have a numerator, then your denominator is just 1, right? Because whenever you divide something by 1, its value doesn't change, okay? And now you can cross multiply. Okay, so when you cross multiply, so 1 times sine theta is just sine theta, okay? So I'm going to be consistent with my color. So 1 times sine theta is sine theta, right? Using this, Jessica, right?
Yeah.
And then, so you multiply this, you put an equal sign, and then it's 1 over 5, right? So if you want, it doesn't matter how you're multiplying. You could if you want, okay, if you want to use the numerator first, then it's 2 square root of 6 times 1 over 5. And then, you can just combine it together, right? So remember, the denominator is just 1. So your numerator becomes 2 square root of 6 times 1, which is 2 square root of 6. And then 1 times 5 is just 5. That would be the best way of doing it. But to do this, I guess you need to do a little bit of algebra.
Okay.
And does that, so Shailene, does that make sense?
Yeah.
Okay, did you draw it out to get the answer or?
No, I kind of just looked at the numbers because, like, if cos is like 1 over 5, then wouldn't you just use 5 to go on the bottom of sine anyways? And then use 2 over 6 to be at the top anyways, because it's like, that's what the formula for sine would be.
Okay, yeah, so you kind of like, you kind of use the formula, but like without, you kind of like, yeah, I get it, but that, which is fine. So you use intuition more than the formula, but you essentially ended up using the formula. Now, what if you draw this out? You could, right? So you see, they're telling me that tan is a positive ratio. So let's start with cos. Okay, so the way I would do it, right? So let's start with cos. So I know that cos is 1 over 5, right? But cos is my x coordinate, isn't it? Right? So this is 1 over 5 over here. So cos is 1 over 5. That means sine could either be positive or it could be negative, right, guys? If you draw it out. And I think this is what you did, Jessica, right?
Yeah.
Right. Now, just, connected to the origin. But I'm only going to be focusing on the top triangle instead of the bottom one. And the reason for that is because in the bottom one, my sine value will be negative. And if my sine value is negative, then my tan value has to be negative. Okay. But because my tan value is positive, that automatically eliminates this possibility. Okay. So that means you only have to focus on this triangle. Does that make sense?
Yep.
Okay, because if tan is positive, and also remember, tan can only be positive in the first quadrant and in the third quadrant. Okay, so that means, usually you have 2 possibilities, but in this case, you have to reject this one because your tan value is positive and focus on this only. So I know that this is 1 over 5, and I know that I guess I don't know what my I value is, right? But I know that tan theta, which is equals to opposite side, right? So this is my reference angle. So the reference angle. So the side opposite to that, which is y, over at my adjacent side, right? Because tan comes from TOA, so it's opposite over adjacent. Okay, so adjacent is 1/5. But you know the value of tan, right? So you know that tan is actually 2 square root of 6. So I'm going to replace this by 2 square root of 6 is equals to y over 1/5. And then just solve for y, which is what we did up here. Okay. Here. So once you solve for y, then I mean, then you will get the answer. But I guess the best way of doing this is, yeah, you will get the answer. So it boils down to the same thing. But I guess the best way would be to figure out what your hypotenuse is, right? So you'll have to square 5 square y and then take the square root of that. But then your r value, I think, will just be 1. Okay, so I wouldn't do it this way, guys. Okay, so I would just, I mean, it still works. I've shown it to you, but to make things really easy, just go with this. Okay.
Okay.
Yeah. So tan,
Yeah,
I guess see this this is something that I should have added in my notes. So this is an important identity, right? The tan is equals to sine over cos. I did show it to you in the notes, but I kind of like mentioned it. I never used it in my examples that oftenly, I guess, for you to realize how important this fact is. Okay, so tan is sine over cos.
Mm-hmm. I think what really got me is because I tried to use the diagram, but I for some reason had the impression that you could only, like if you, I don't know, for some reason I thought the hypotenuse would always be 1, and I don't
Oh,
know why.
okay, yeah. You could, if the hypotenuse is not given to you, you could make it equal to 1 if it's not given to you. Okay.
Okay.
What do I mean by that? It's kind of hard, I guess. Okay, let's just think about it this way. When you're solving for an angle, okay, when you're solving for an angle, then your hypotenuse has to be 1. Okay.
Oh,
When you're not solving for an angle, then it's not necessarily 1. Okay, because if you have your x value and your y value, then your hypotenuse will be calculated using the Pythagorean theorem.
mm,
Okay, only when let's just keep it simple. Only when you're solving for your angle, that's only when you can assume your hypotenuse to be 1.
okay.
Otherwise, you're going to have to calculate that using the Pythagorean theorem, okay? Because you're going to have enough information to compute your hypotenuse.
Okay.
Yeah, but I would just avoid doing it this way altogether and just use this special identity. And that way,
Okay.
I think it's much easier. Any other questions?
That was the only one from me.
Shailene, are there any more questions?
No.
No? Oh, okay. So I thought well, are you guys comfortable with finding the angle and stuff like that? So that I thought that would be the most challenging part of this week's lesson, I guess.
No.
Finding the angle is good.
Yep.
Yeah.
Okay. And also finding the angle for tan, I think, is much easier, right? Do you guys get the way I did it?
Yeah.
Yeah, tan is really easy. Just use your calculator and then add 180 to the solutions that you have. There's going to be 2 solutions all the time, right? So if the first solution, if the calculator gives you a negative number, then you're going to have to add 180 twice to find both solutions, okay?
Mm.
Oh, okay. So, you know what? Well, okay. I mean, I don't want to waste, I guess, your guys' time too much. So I will extend the quiz for the other students. I'm gonna post my recordings up there soon as well. So quiz will still, I'll make it available at 9 a.m. tomorrow. Um, you know what? I'm gonna actually make the quiz available at 12 p.m. tomorrow. So at noon, because I want to have the office hours. I see. I don't want to give you the quiz and then hold office hours, because then you will know what questions to ask, right? That's the thing that's kind of bothering me. So um okay, I'll just make the students vote. So I can make the quiz, I guess, available after 3 p.m. tomorrow, so that students can come ask me questions anytime during the day. And make it due at midnight, but on the next day, on Saturday. Or I can just make the quiz available the way I was hoping to make it available. Um, I don't know. I'll just ask the students what they want. Okay.
Okay.
Yeah, yeah. So sorry about that. I hope I was able to answer your questions. And next time I'm gonna be a little bit more careful. Okay.
Yep.
Thank you.
Okay. Take care,
Thank you.
guys. Bye.
You too. See ya.